Now, nowadays there is something which is quite frequently coming in the newspapers and the media, like with respect to Japan, with respect to Australia, with respect to US, with respect to Russia, and that buzzword is something we call as nuclear deals. Like this started on 18th July 2005 when Mr. Manmohan Singh, as a Prime Minister, signed a civilian nuclear cooperation with United States of America. And that civilian nuclear cooperation, then after that, India has gone for similar type of agreements with Russia, with France, with Kazakhstan, with Mongolia, with Australia, with Nigeria, with Canada, and the list is growing by day. Now the general thing is, like, what exactly the nuclear deal is? Sometimes we think that nuclear deal, some of the students do have this misconception that nuclear deal is about something they will give in the form of nuclear weapons. That is absolutely not the case. Actually, nuclear deals, we need to answer the following things with respect to nuclear deals. Like, first, why India has to sign these deals? This is the first question. Second is, what are the components of nuclear deals? And another question is, what are the impediments in realizing the potential of these deals? So if you can answer these three questions, then obviously general framework like what is nuclear deal is something we have developed. The first thing is why India has to sign nuclear deal. Like you may get a question in mains. Discuss the criticality of the nuclear deals with respect to energy security scenarios of India. The criticality is the important word. That means that relevance of the nuclear deals for India to move towards being an energy secure country. On these lines we have to argue that, as far as the importance of nuclear deals is concerned. See, nuclear deals, we had a target. We means Government of India had a target that by 2032, India need to produce somewhere 63,000 megawatt of electricity from nuclear sector. That is only nuclear sector. The question is, to produce this much of electricity, two definite things we require. First is technology, and the other is a fuel. Now fuel here means nuclear fuel. So we need nuclear fuel, we need technology. Now what do I mean by technology? Actually by technology, I mean two things. First two. First is nuclear reactor, and second, or rather reactors, and second E and R technology. What is E? Enrichment. What is N? And what is R? Reprocessing. So these are the things we require to produce this much of electricity from this particular sector by that particular time. What is the issue? Issue is, as all of us know, in terms of uranium, we are one of the poorest. We means India is one of the poorest. So given the reserves of uranium India is having, domestically, of the total fuel requirement, India can fulfill only 20%. Means if we require, say, for example, 10 ton per annum, example only, hypothetical case, then we will be able to produce only 2 tons of uranium in 1 year. So it's very simple. If you do not have the required quantity of fuel, then you will not be able to produce the required electricity also. This is one thing. So first and foremost thing, what the nuclear deals will do for India, it will ensure the availability of nuclear fuel. Nuclear fuel will be provided by all the countries, whether it is US, Russia, France, Mongolia, Kazakhstan, Nigeria, Australia, all they will provide nuclear fuel. Okay, fine. What is the other aspect? We will also get nuclear reactors. Reactors will be provided only by 3 countries as of now. Who are these 3 countries? US. US is providing 12 reactors, 6 for Mithi Virdi in Gujarat and 6 for Kovada in Andhra Pradesh. Then France is providing 6 reactors for Jaitapur in Ratnagiri district of Maharashtra. Then Russia is providing 6 reactors for Kudankulam in Tamil Nadu. Okay, fine. Besides that, India is also expecting ENR technology. Now, ENR technology will decide the future of the Indian nuclear power program. Now, enrichment and reprocessing I will explain here, because if I will not explain these 2 terms, then obviously some of you will find it a bit difficult. See, enrichment. What is enrichment? Uranium. Naturally occurring uranium has 2 types of isotopes, rather 2 isotopes. One is uranium-235 and the other is uranium-238. Out of these 2, the distribution is uranium-235 is just 0.7% and 238 uranium is 99.3%. Okay, fine. What is the problem? The problem is this uranium-235 is fissile, whereas this uranium-238 is fissionable. Now, what is the difference between fissile and fissionable? See, fissile. Fissile means that when uranium-235 is bombarded with neutron, it will break down into 2 lighter elements. For civil service, we are not supposed to remember X and Y. Plus, it will give on an average, I am using the word on an average, 3 neutrons, plus there is heat. This heat is something we use for converting liquid water into steam, and that steam rotates the turbine and we get the electricity and so on and so forth. But then what is fissionable? In case of fissionable, which is uranium-238, if we use neutron to bombard uranium-238, it will not directly break down like uranium-235 has. Rather, it will transform into another element, that is plutonium-239. And this plutonium-239 is fissile. So this is known as fissionable or fertile. So uranium-238 is fissionable or fertile, whereas uranium-235 is fissile. Similarly, there is one more element which is of relevance for us, that is thorium-232. Thorium-232, as all of you might have read in newspapers or somewhere else, that India is India is the richest country in terms of the availability of thorium. The thorium is again fissionable or fertile. That is, when it is bombarded with neutron, it will change into uranium-233, and this uranium-233 is something which is fissile. So again, thorium-232 is also fertile or fissionable material. So I was explaining to you enrichment. See, what is enrichment? Naturally occurring uranium is having two isotopes, that is uranium-238 and uranium-235. So naturally occurring uranium, as I said, is comprised of uranium-235 and 238. Out of that, uranium-235 is just 0.7%, whereas uranium-238 is 99.3%. The issue is something which is 99.3% is not fissile, and something which is fissile is just 0.7%. So enrichment is the technology which helps in increasing the percentage of uranium-235 in the overall mixture. I'll just explain this with the help of a simple example. Like, say for example, you are having 10 balls. 2 are white, 8 are black. Percentage of white is something, what you can say, 20% easily. Now in this next scenario, what you have done, you have removed 5 balls. When you have removed 5 balls, you are left with just 5 balls. But which 5 balls you have removed? You have removed 5 black balls. So when you remove 5 black balls from 8 balls which were black, then you have got only 5, out of them 2 are white, 3 are black. Now in this case, the percentage of white has gone up to how much? It has gone up to 40%. Similarly, when from a mixture we keep on gradually, slowly removing uranium-238, in the leftover mixture we have a higher percentage of uranium-235. And to do this, we need a technology known as centrifuge. So centrifuge is a device used for carrying out the enrichment of uranium. Okay, fine. On the basis of enrichment, uranium is of two types. One is low enriched uranium and the other is highly enriched uranium. LEU and HEU. LEU is used for civilian purposes like as a fuel in a nuclear reactor. And HEU is known as weapon grade uranium. Weapon means nuclear weapon. So this says everything. That HEU is for military purpose and LEU is primarily for the civilian purpose. So under nuclear deals, either India will get natural uranium, natural uranium, that is 0.7% uranium-235 and 99.3% is uranium-238, or else India will get low enriched uranium. Low enriched uranium, like I'll give you an example. The Kudankulam reactors provided by Russia using 1.5% enriched uranium, and this fuel has to come from Russia. Similarly, Jaitapur reactors provided by France uses 5.5% enriched uranium. That is again has to come from France. So we'll get the technology which is enrichment. Now what is reprocessing? See, reprocessing is vital from the future perspective of the Indian program. How? This way. In reprocessing, what happens? We take out useful elements from the spent fuel rods. Now here the term which is important for you to know is spent fuel rod. Now some of you, while listening this recording, might be having a question that what about those useful elements? Which useful element I am talking about? Actually, it is like this. Just now I said that the Kudankulam reactors are using 1.5% enriched uranium. What does it mean? It means this. If I am having 1 kilogram of 1.5% enriched uranium, that means 15 gram is uranium 235 and the remaining, that is 985 gram, is what? Uranium 238. And this thing goes in the form of a rod in the nuclear reactor. Now inside the nuclear reactor, what happens? That uranium 235 is consumed and exhausted. But simultaneously what is also happening, that this uranium 238, as a fraction of this uranium 238, gets converted into another element, that is plutonium 239. So this fuel rod, which has exhausted the uranium 235, when it is taken out from the nuclear reactor, that rod is basically, we call it as spent fuel rods. And this spent fuel rods, if I see broadly, is having three types of things. First, leftover uranium 238. Then another is plutonium 239, which has formed from uranium 238, plus you can see nuclear waste. Obviously, these two are very vital, that is uranium 238 and plutonium 239. So what we do in reprocessing, we put this spent fuel rod in certain chemicals, and in those chemicals this rod dissolves. And from that, the useful elements like uranium 238 and plutonium 239 or other elements which could be there are extracted. So this process or this technology which allows the extraction of the useful elements from the spent fuel rods is known as reprocessing. So under nuclear deal, India will get fuel, India will get nuclear reactors, and India will get ENR technology. But let me add one rider here. Only 3 countries will give India the technology, that is reactor and the ENR. And those 3 countries are US, Russia and France. Rest of the countries, Japan, still things are not properly defined, so I will not comment on that. But rest of the countries are simply going to provide the fuel which is nuclear fuel. So under nuclear technology, India is going to get these 3. But obviously, any deal is give and take. So the important question is what India has to do in order to get this technology. That we will continue in the next part of this series. Thank you.